Okay, so in this video, we're going to look at finding the gradient at different points of a curve, and we're going to look at what that can tell us then about the curve once we've found the gradient at different points. So the question is, show that the tangents to y equals x cubed have positive gradient everywhere except the origin. Okay, so first of all, what we're going to do is draw the curve. Okay, so I know that the curve is going to go through 1, 1, and I know that it's going to go through -1, -1. So I'm going to try and draw the curve now. It's going to go something like this. And there we go. That's pretty good. Okay. And I'll draw arrows on the end to show that it's going to go on forever. Okay. So to find the gradient at different points, what we're going to do is find the derivative first of all. So I'm just going to differentiate that curve. So the derivative is going to be 3x squared. And then what I'm going to do is choose 2 points on either side of the origin, okay? So I'm going to choose -1, -1, and then 1, 1. So those 2 points that I highlighted earlier. And what we can do is just substitute the x value of each of those points into the derivative and see what happens. So when x equals -1, the derivative is going to be x squared, which is -1 squared times 3, which is just going to be 3. Okay, so the derivative is going to equal 3. And that's a positive result. Okay, so that's what we were after. And if we just try to visualize what's happening with that. So let's have a look at the curve, and we're looking at the point -1, -1. And I'm just going to try and draw the tangent at that point. All right, just imagine that goes through that there. And you can see from this tangent that it's sloping upwards. Okay, so it's sloping upwards, it's increasing as we go, and that means that it's got a positive gradient as we saw here with the derivative. Okay, so that shows us that on the left of the origin, so here on this side of the origin, the curve is always going to be increasing because you can just see from the direction of the curve there that it's always going to be sloping upwards in that same direction. So let's have a look at the other side now. So we're going to look at this point 1, 1, and I'm going to substitute this point now into the derivative. So when x equals 1 this time, the derivative is going to equal 3. It could be because it's x squared. So 1 squared times 3 is just going to be 3. And that is another positive result. Okay, so we've got two positive results, which is what we were expecting. And I'll just try and draw the tangent again. So it's going to look something like this on this side. All right. Yeah. And we can see that again, that's sloping upwards. Okay, so it's increasing. The curve is consistently increasing as we go along this way. And we can see that it's going to keep doing that as we go up the curve. So you can see we've got two positive results, which is what we're expecting. And yeah, it's gonna keep happening on either side of the curve. Let's have a look now, just as a little bonus at what happens at the origin. Okay, so when x equals 0, we can just put the x coordinate into the derivative there. The derivative is going to equal 0. Okay, and if you've done any calculus in the past, you'll know that that's a significant result. When the derivative equals 0 on a curve, there's usually something pretty interesting happening. So that's definitely something we'll come back to in future videos. And just to try to show you what that's going to look like. So if we look at the origin at the point at which x equals 0, I'll try and draw the tangent here. It looks something like this, okay? And you can see that it's going in a horizontal direction. So yeah, again, something interesting is always going on when the derivative equals 0. So yeah, we'll come back to that. But hopefully you can see from this video that finding the gradient at different points on a curve can tell you a lot about what the curve looks like and what happens at different points on the curve.